Good morning everyone. Welcome back to grade 5 mathematics class. How are you all doing today? So we have been learning about prime numbers, composite numbers, co-prime numbers. We have learned about prime factorization, and today we will learn about the highest common factor or HCF of two or more numbers. Now look at these two numbers given here. We have 6 and 12. Let's see the factors of 6 and 12. So 6 can be written as 6 is equal to 1 into 6, right, and 12 can be written as 12 is equal to 2 into 6. So these are the factors of 6 and these are the factors of 12. We know the factors of a number can divide a number completely, means without leaving any remainder. So what is 6 divided by 6? It is 1, or 6 divided by 1 is equal to 6. Similarly, 12 divided by 2 is equal to 6 and 12 divided by 6 is equal to 2. There are no remainders. The factors divide the given numbers completely. Which is the factor that is common to both these numbers? Is it 1, 2 or 6? 6, right? So 6 is a factor common to both 6 and 12. So that is the common factor, and that is also the highest or the largest common factor to 6 and 12. So we can say 6 is the highest common factor of 6 and 12. So what are highest common factors? So highest common factor or HCF of two or more numbers is the greatest number that can divide the given numbers completely, that is without leaving any remainder. Now we know the number that divides another number is called the divisor. So this HCF can also be called as the greatest common divisor or GCD. Let's do one question now. Find the HCF of 12, 24 and 36 using prime factorization method. So we have learned about prime factorization in our earlier classes. So what is prime factorization? When a number is expressed as the product of its factors which are only prime numbers. So such factorization is called prime factorization, and let's see how we can find the HCF using prime factorization method. So first let's write down the prime factors for each of these numbers. So how can we write 12? 12 can be factorized as 2 into 2 into 3. 2 into 2, 4 into 3, 12. What is 24? 24 is 2 into 12. So we can write this as 2 into this, 2 into 2 into 3. Now what about 36? 36 can be prime factorized into 2 into 2 into 3 into 3, right? So here we have all the numbers prime factorized. Now do you see some factors which are common to all these three numbers? Yes, we have 2 that is common to all these three numbers, and this 2 is also common to all these three numbers. And what about this 2? It's not common to 12 and 36. It's only in 24. So what about this 3? Yes, this 3 is also common in all these three numbers. Now what do? We have to take one from each group and then multiply these common factors, and the resulting product or the answer will be the highest common factor for these numbers. So in this case, let's take 1 2 from here, from this group, and 1 2 from this group, and 1 3 from this group. So it is 2 into 2 into 3, 4 into 3, 12. So for the numbers 12, 24 and 36, the HCF by prime factorization method is equal to 12. I hope this is clear to you. Now we will do one activity. You have to note down this question in your notebook. Find the HCF of 28 and 42 using prime factorization method. You can pause the video, finish the exercise and come back. I hope you have finished doing that activity. Now let's discuss the answer. Now for this question, what do you have to do? First we have to find out the prime factors for the given numbers. So 28 can be factorized with prime factorization as 28 is equal to 2 into 2 into 7. What about 42? 47 can be written as 42 equal to 2 into 3 into 7. All these factors are prime factors. Now what do? We have to group together the common prime factors for these two numbers. So 2 is this 2 is common to both these numbers, and this 7 is also common to both these numbers. Now what do? We take one from each group and multiply the numbers, the factors together, and the product will be the HCF. So here it is 2 into 7, 14. So HCF of 28 and 42 is 14. So I hope your answer is correct. Now we will see a different method to find the HCF. So we learned about the prime factorization method to find HCF. This method is called the short division method to find HCF. See, here we have the question, find the HCF of 12, 24 and 36 using short division method. So in this method there are a few steps that you need to follow. So the first step is to divide the numbers, all the numbers. If 2 or more numbers you will be given, so you have to divide all the numbers together with the smallest common prime factor for all the numbers, and you get some quotients, and you write that quotients right below the respective numbers. Then again you have to find a common prime factor for the quotients just obtained, then divide those quotients with that common prime factor. You repeat the process, you continue the division until where there are no more common prime factors to proceed the division further. Once you are done with the division, what do? You take all the common prime factors, you find the product, and that product will be the HCF. Let's see the steps once again. So here you have the question 12, 24 and 36. Now first we have to write these numbers. Then we have to find a common prime factor for all these three numbers. So I am drawing one grid here. So I drew like this, and 12, 24, 36. All these numbers have an even number or a multiple of 2 in the ones place. It means that all these are multiples of 2. Hence these three numbers will be completely divisible by 2. So the smallest common prime factor for these three numbers is 2. Now what do? You have to divide each of these number by 2 and then write the quotient below the respective numbers. So here 12 divided by 2. What is 12 divided by 2? It is 6. So you write that quotient right below 12. You put a comma. Then you divide 24 by 2. What is 24 divided by 2? It is 12. You put a comma. You write that 12 below 24. Now 36 divided by 2. What is 36 divided by 2? It is 18. Here we have the quotients. Now what do? We have to find out a common prime factor for these three quotients. See, all these are even numbers. So all these numbers can be completely divided by 2. So again we are dividing these numbers with the smallest possible common prime factor for these three numbers, which is 2. Now what do? We divide all this. So 6 divided by 2 gives what? 6 by 2 is 3. Put a comma. 12 divided by 2. What is 12 divided by 2? It is 6. A comma. Now 18 divided by 2. It is 9. Now you have 3, 6, 9 as the quotients. Now what is the smallest possible common prime factor for these three numbers? Can we use 2 to divide all these three numbers? No. What about 3? And is 3 prime? Yes, 3 is prime, and you can use 3 as a divisor to divide all these three numbers. Why? Because these three numbers are multiples of 3. So let's take 3 and write 3 here. Now 3 divided by 3 is 1. Any number divided by that number itself equal to 1. Now 6 divided by 3 it is 2, comma 9 divided by 3. What is it? It is 3. Now, these are the new set of quotients. Now, do you see any common prime factor that can divide all these 3 numbers exactly or completely? No, there are no more common factors for these numbers. So, that's where you stop the division. You stop the division right there. Now, here on this side, you have all the common prime factors which divided all these numbers, all these 3 numbers completely. So, you take those prime factors along, these 3 common prime factors. Then what do? You have to multiply these 3 common prime factors. So, here it is 2 into 2 into 2, 3. So, 2 into 2, 4 into 3, 12. So, there you have the HCF. HCF of 12, 24 and 36 by short division method. Did you notice earlier when we found out the HCF using prime factorization method, the HCF was 12, and here also the HCF is 12. So, the HCF remains the same no matter which method you are using to find out the highest common factor. So, I hope this is clear to you. Now, we will do one activity. You can note down this question in your notebook. Find the HCF of 36, 64, 96 using prime factorization and short division method. You can pause the video, finish the activity and come back. Hope you finished doing that activity. Now, let's discuss the answers. So, first let's do the prime factorization method. So, we have the numbers prime factorized. So, the first number is 36. 36 can be written as 2 into 2 into 3 into 3. Now, what about 64? 64 can be written as 2 into 2 into 2 into 2 into 2 into 2. So, 96 is equal to 2 into 2 into 2 into 2 into 2 into 3. So, here you have the numbers prime factorized. Now, what is the next step? You have to find out the common prime factors and group them together. So, let's group the prime factors, common prime factors. So, this 2 is common to all these 3 numbers, right? This 2 is also common to these 3 numbers. Now, what about 3? 3 is not there in 64's factorization. So, you don't take that 3. Any more numbers? No. So, here you have one group of 2's and the second group of 2's. So, you take 1 from each group and you multiply. So, what do you get there? 2 into 2, which is equal to 4. So, the HCF of 36, 64 and 96 is equal to 4. Now, that was the prime factorization method. Now, let's do the second method using short division. So, for short division, what do? You write the numbers alongside, then you find a common prime factor for all the numbers. Here all these numbers are multiples of 2, or all these numbers end in multiples of 2, and hence we can divide all these numbers by 2 completely. So, you divide that by 2. 36 divided by 2 will give you 18. 64 divided by 2 will give you 32. 96 divided by 2 will give you 48, right? So, this is the first set of quotients. Again, you have to divide with a common prime factor. Here, you can divide all these numbers together by 2. So, dividing 18 by 2 will give you 9. 32 by 2 will give you 16, and 48 divided by 2 will give you 24. Now, can we divide these numbers or these quotients again? Can we use 2 here? We can use 2 to divide 16 and 24, but not 9. You can use 3 to divide 19 and 24, but not 16. So, you cannot have you don't have a common prime factor which can divide all these 3 numbers together, right? So, that's where you stop the division. Now, what do? You have to take all the common prime factors which could divide all the numbers completely. So, here you have 2 and 2. You take those 2's and you multiply that. 2 into 2, multiplying them together gives you 4. So, that is the HCF of 36, 64 and 96 by short division method. So, I hope this was clear to you. You can go through the topic, the highest common factor, to find HCF by prime factorization method and to find HCF by short division method, which is in page number 43 and 44. And once you have done that, you have to move on to exercise 3.3. The first question, question 1a, we have already done in the class. You have to complete the other questions, that is 1b to 1l. Once you have done that, you can take a picture and send us. So that's all for today. We'll meet in the next class. Until then, bye.